Imagine an AI that not only answers your questions, but thinks like a human, critically analyzing its own reasoning before responding. OpenAI's O1 series marks a revolutionary leap in AI, introducing models that prioritize reasoning and critical analysis, transforming how AI tackles challenges. Unlike previous generations, these models don't just generate answers. They think through problems, unlocking new possibilities in areas like complex math, coding, and creative tasks. Whether it's decoding encrypted languages or designing intricate video games, the O1 series showcases a deeper level of intelligence, offering unprecedented potential across a range of fields. OpenAI has recently introduced a new series of AI models called O1 Preview and O1 Mini. These models are designed to offer a different approach compared to previous models like GPT-4. Unlike their predecessors, O1 models are positioned as reasoning models. This means they prioritize careful thought and analysis before providing answers. O1 Preview. This version offers a glimpse into the capabilities of the O1 series. O1 Mini, a smaller, faster model built on the same framework as O1. The O1 models represent a major breakthrough in math problem solving by introducing a higher level of reasoning and self-reflection. Unlike previous models that often followed patterns without scrutinizing their assumptions, O1 actively evaluates its own thought process, identifying mistakes and refining its approach. This ability to reflect and correct its reasoning leads to more accurate and reliable results, showcasing the model's advanced capabilities in critical thinking and logical problem solving. O1 model has the ability to solve more complex tasks. Let's take the first example of Korean language. In this demonstration, we'll explore how reasoning models handle a complex task, decoding a badly corrupted Korean sentence. The goal is to show how different models, particularly GPT-4 and the new O1 Preview model, approach this challenge. We start by inputting the corrupted Korean sentence into GPT-4, asking it to translate the sentence into English. Since the text is badly corrupted and doesn't follow typical language rules, GPT-4 struggles to understand it. The model correctly identifies that the sentence is invalid, which is understandable given the nature of the text. Now input the same corrupted sentence into the O1 Preview model. Unlike GPT-4, O1 Preview begins by thinking through the problem and decoding the garbled text before providing an answer. The model takes a decoding approach rather than simply translating, which is the right direction for solving this problem. The model is currently deciphering the corrupted text, recognizing it as a decoding task. It is successfully decrypting parts of the text, demonstrating a deeper understanding of the corrupted sentence. The model is expected to produce the final translation within 15 seconds. No translator on Earth can do this, but Koreans can easily recognize it. To showcase the advanced capabilities of O1 Preview, let's consider a coding challenge: creating a simple video game called Squirrel Finder. This game requires the player to navigate a koala through a field, avoiding strawberries and searching for a hidden squirrel. O1 Preview's ability to reason and plan before generating code sets it apart from previous models. The player controls a koala using arrow keys. Strawberries randomly spawn and bounce around. The goal is to find the squirrel that appears after 3 seconds. The game should display OpenAI on the screen and provide instructions before starting. Before generating code, O1 Preview took 21 seconds to carefully consider the game's requirements. It mapped out the game's structure, designed the screen layout, and planned the mechanics for character movement, strawberry spawning, and squirrel appearance. This thoughtful approach ensured a well-structured and functional code. Upon testing the generated code, the game performed flawlessly. The instructions were displayed correctly, strawberries appeared as expected, and the squirrel's timely appearance provided a challenging gameplay experience. The game's mechanics were smooth and responsive, demonstrating O1 Preview's ability to create efficient and effective code. Building code that runs consistently and works efficiently takes a lot of effort. What's exciting now is that with advancements in AI, every person will be able to build much more, and there's still so much more to create. This is what makes the new O1 model so exciting. The new O1 model stands out because it processes information and makes decisions in a more human-like manner. Scott explains that they collaborated with OpenAI, provided feedback, and tested the O1 model. The result was impressive, particularly in reasoning tasks. At Cognition AI, they are building Devon, the first fully autonomous software agent. Devon is capable of building tasks from scratch and solving problems like a software engineer. As an example, Scott asked Devon to analyze the sentiment of a tweet by utilizing different machine learning services. Devon starts by planning its approach. In the example, it faced difficulty fetching the tweet from the browser, so it decided to access the tweet through an API. These small, human-like decisions showcase the power of reasoning. In the end, Devon successfully analyzed the tweet and determined that the predominant emotion was happiness. O1 Preview's ability to reason and plan before generating code sets it apart from previous models. Let's dive deeper into OpenAI's O1 series through exciting experiments. Watch as the O1 model tackles nonogram puzzles with logical precision, engages in a poetic showdown where creativity meets constraints, and even builds a small HTML game from scratch. Experience the power of reasoning in AI like never before with the O1 series. Nonograms, also known as Japanese crosswords or Picross, are a popular logic puzzle. The objective is to fill in a grid based on numerical clues provided for each row and column. These clues indicate the number of consecutive filled squares in a given row or column. In this exploration, we'll demonstrate how the O1 model can be used to generate and solve nonogram puzzles. We can instruct the O1 model to generate a nonogram puzzle of a specified size. The model will create a grid and assign appropriate numerical clues based on a predetermined pattern or image. For instance, we might ask the model to generate a 5x5 puzzle that resembles the letter M. Once the puzzle is generated, we can input it into another instance of the O1 model. The model will analyze the clues and employ logical reasoning to determine which squares should be filled. It will iteratively consider possibilities, eliminate contradictions, and refine its search space until it arrives at the correct solution. The key to solving nonograms lies in understanding the clues. Each clue represents the number of consecutive filled squares in a row or column. For example, a clue of 2 indicates 2 consecutive filled squares, while 1 suggests 2 separate filled squares. By carefully interpreting these clues and applying logic, one can gradually fill in the grid until the complete image is revealed. Let's see another example. Write a 6-line poem about squirrels playing soccer with koalas, adhering to specific constraints. Line 2, last word ends with I. Line 3, second word begins with U. Line 5, second to last word is eucalyptus. Final line, all words have 2 syllables. GPT-4, while capable, often struggles with prompts that require strict adherence to constraints. It tends to generate a response without fully considering all the rules, leading to errors or incomplete fulfillment of the requirements. O1 Preview, on the other hand, demonstrates a more methodical approach. It brainstorms, words and phrases, a list, checks constraints, carefully verifies, meets the rules, refines, adjusts the poem, aligns with the goal. O1 Preview's approach resulted in a poem that perfectly meets all the given constraints. Line 2, Safari ends with I. Line 3, Unleash begins with U. Line 5, Eucalyptus is the second to last word. Final line, all words have 2 syllables. Now try implementing a small game in HTML, enhancing the snake game and adding obstacles. Goal: to make the snake game more challenging and visually interesting, we'll introduce obstacles that spell out AI. Implementation: create obstacle array. Define an array of coordinates representing the positions of the obstacles. Check obstacle collisions. During each game update, check if the snake's head collides with any of the obstacles. If so, end the game. Visualize obstacles. Use CSS to style the obstacles, making them distinct from the snake and the playing field. Result: with the obstacles in place, the snake game becomes significantly more clear. It shows the power of this model by OpenAI. This addition not only increases the challenge, but also provides a visually appealing element to the game. O1 Preview's ability to reason and evaluate different options before responding is crucial for tasks like this. It can effectively consider the impact of the proposed changes on the overall game experience and make adjustments to ensure a balanced and enjoyable gameplay. The O1 series is more than just an upgrade. It's a complete transformation in how AI approaches problems. From solving complex mathematical equations to designing video games with intricate mechanics, the O1 model demonstrates a deep reasoning capability that previous models like GPT-4 struggled to match. As we look toward the future, it's clear that AI like the O1 series will continue pushing the boundaries of what machines can achieve, offering solutions that are not only faster, but also smarter. Get ready to explore a future where AI doesn't just think, it reasons. That's it for today's showdown. Do you prefer a 1 preview and a 1 mini? Let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon for more exciting AI battles. Thanks for watching.